haven't seen that since fourth grade.
Did you get 100 on it, Brighton?
Yeah, I got 100 on mine.
I did. I did.
Sorry,
Yeah, it's a lot.
Exactly. Now you listen, when he had 22, then he's like, nope.
I'm doing good at math.
You know what I did? I was sitting there and I looked Mr. Everson, are you pro to me?
So, did you understand her?
Yeah, I got it.
I found this paper.
Well, right.
And it was just like,
It's my lucky day. Yeah.
I didn't get it wrong.
wait, who's this like? I don't know. Paris father. Blue.
Dude, that's mine. That's mine. Yeah, dude. I printed that out. I'm typed that out.
Go Weston.
I gave him the tape and I gave him the
Should only take you a couple minutes to do it. When you get finished, lay it up here on the blue chair. Sit quietly until everybody's finished. Arc, what's an arc?
It's a part of the perimeter of the circle in which it's separated by some
All right.
fade out.
Chord.
An arc is 2 points on the circle and all the points that fall in between them. That's an arc. All right. What's a chord?
segment inside of the circle.
A segment. Now, be careful.
Think it was
That connects.
That connects
Two
two parts of the circle.
All right. 2 points on the circle connected. Unlike an arc, a segment, 2 points on the circle, and the segment that connects them, not the, the rounded part.
So is the diameter
A diameter is, the whole diameter is a,
The perimeter of the circle.
what is that? It's not a chord, it's a, oh no, diameter, I'm sorry, I'm thinking circumference.
Oh,
Diameter is a chord. What's special about a diameter? This is one of them that's on your homework tonight.
Doesn't
Like
it go
it's half the
straight across
No.
or something like
Split the circle in half.
It's pi r squared. Lols.
If I was to draw 1,000 chords inside a circle, what could you tell me about the diameter? That chord, it's the longest one. The diameter is always the longest chord of a circle. Give me something else.
Radius.
A radius. What's a radius? Even though
Half diameter.
I'll accept
Pi
the
r squared.
I'll accept a radius on this, even though, did you know radius before you ever came in here today?
But
No,
we
but
can
you
talk about it in
said
this
discuss
class.
this year.
All right, and that's why I said
That's why I put it. I was a little
That's why I said I would accept it. So, what's a radius? Give me a good definition then.
half the diameter.
Yeah, it's not a good definition.
point from the center of the circle to the edge.
Point, center of the circle to the edge of the circle. Or not a point, but I said the same thing that he said.
Segment.
A segment that connects the center of the circle to some point on the edge of the circle. Give me something else.
that.
Semicircle. What's a semicircle? Now be careful when you say that. Half a circle. That means if I took that circle I was holding up there and cut it in half, that would be a semicircle?
Yeah.
Semicircle is
Part of a
the,
circle that's not.
Half of the circumference.
exactly, it's the arc. A semicircle is the actual arc, not the circle, not the inside part.
So you could have a semicircle with this arc and not like the bottom.
Right, so a semicircle might look something like,
Mr. Bryan in here.
that would be a semicircle. Alright?
What about if you go all the way over and it doesn't connect? Is that a semicircle?
All the way over and it doesn't connect. What do you mean?
So if you go like
But
straight up.
you keep going, but it never connects to the other point.
That is not a circle.
So like that.
Yeah.
But that's
It's,
something good.
it's not a semicircle then,
Yeah.
Okay.
because it's not half of the distance around the edge of the circle. Does anybody know what kind of, a semicircle, this from here to here, is half of the circumference of the circle. And that, it's an arc still. Does anybody know what's special about this arc? That,
It's major arc.
What?
How'd you know
say it
that?
louder.
Major arc.
It's a major arc.
How'd you know that?
It's
So then what's a minor?
Because you
arc?
read it.
So then what's a minor arc?
So what would a minor arc be?
less than half.
Less than half. So something from like here to there would be a minor arc. Major arc goes around farther, semicircle. Goes exactly halfway.
They should start teaching that when we learn about circles in like first grade.
Yeah, they just don't
I
figure
would have
it.
like
Yeah, but, like,
wrecked
first
my
grade,
little
like-
brain.
That you're
back
quite-
then.
Right? No,
Ready
they're
for
giving
it.
that more messed up.
Give me another
I
one.
couldn't even do multiplication.
Any others?
Secant or
A secant. We talked about a secant. What was a secant?
a line.
A
A
line that
segment.
does what?
Connects 2 points to a circle.
Goes through the circle.
Alright, so that's a secant.
It's a line, right? Not a segment.
Right, it's a line.
Because
Because if it was just the
Then
segment
it's a
part,
chord.
then it would be a chord. So if you got rid of those, it'd just be a chord. And this actually, when you draw the whole thing in like that, when you have the whole line, anybody have any idea what this chord? It's called a special name then. It's real tough.
Mid-circle.
It's called a
Mid.
Secant chord.
secant
I guessed
chord.
it.
Wow, that was
Wow.
really.
Alright. Any others?
I thought that thing was
Is there a name for a ray?
Inscribed angle. Anybody have any idea what an inscribed angle
Angles
is?
within
It's
shapes
showing
within
Oh, within the
circles.
circle?
An angle within the circle. So that
I don't know.
No, it's an
They
angle
probably
within a
have to
shape within
probably
a circle.
touch, like, they probably have to, like,
Yes,
touch the
that.
side or something like that.
It's
Edge of the
circleception.
So what's this point called? That's the key to all of
A
it.
circle within a circle.
What's that?
Okay.
Oh, I hope you remember this for your final coming up.
It's a vertex.
The vertex, thank you.
Oh, I thought it was like you meant like a
The-
special name that we
yeah.
haven't learned yet.
The vertex of the angle has to be on the circle.
Oh.
Alright, that's an inscribed angle.
You get it come.
What was the other angle? Anybody remember the other one they probably read about?
Uninscribed.
Yeah, that would be the angles that we've been dealing with all year long. We haven't talked about any circles.
It is obviously.
Alright, if you don't remember, we'll get to it here in a minute.
Is there a name for a ray that comes in a
Yes.
circle?
A ray that what?
Ray
Then we
that
just
starts
What?
inside of a circle.
We just learned it. Now
Yeah,
we're
it's
saying we
like
should
what-
write every formula.
It sort of goes right along with secant and all that stuff, and we'll talk about that. On the test. The test, of course, I don't have it graded yet. Today is the 14th. Go ahead and start copying this down.
We start a new section.
I'm gonna run out of paper.
Are you gonna grade or bind this?
So if you don't want to write any of this down, right?
No, not that, but like, can I move all this crap out to the back? But I'm still gonna need it a lot.
Is this chapter 9 or 10?
10.
I just.
You might want to
got
keep
rid
it.
of I
How does
put
he-
it like I left it at home, put it in my room.
Put it somewhere else.
You're
And then I just, all the stuff that I know that I'll need this quarter, I just put in a folder.
Don't get rid of it because the final
I'm not
covers
gonna
the
get
whole
rid of it. I
year.
just
Yeah,
want this
that's
to be the
what-
first thing I see.
Well, that's fine. Then take it out, and there's other
I
binders.
will- I do have a
You can
question.
grab a binder up here and put
Will
that
our-
extra stuff in there.
Will our final be over mostly what we've been learning here lately, or mostly what we've been learning?
Everything
I
from
hope
the
it's
first
mostly
year,
from
so
the
we
first-
don't remember any of it.
I don't want to say either one
Because that was the easy
because
Yes.
everything that we learned, like when we were just talking about angles a second ago, well, to do all the stuff that we're doing now, you have to know all that stuff. So everything that we're covering now, if I had to answer the question truthfully, it's more over the stuff we learned at start. Because everything that we do now,
Is more recent, so they expect
you
to
have to
learn.
know the stuff that you did at start to go with it. So,
Precision? Like,
no.
I get a C on that.
So
How precise.
My-
Very
my point, if we do a problem like on today's assignment,
Yeah.
well, it's about the stuff that we covered today,
And.
but
stuff from, like,
maybe
Well,
25% of it talks about what we did back in chapter 1 or chapter 2 or something. So every problem that we do now has a certain percentage of that problem that deals with that other stuff.
What's precision again?
Beginning of the year now.
It's like how close you are to your like
I didn't realize the consequences of my actions.
Remember that for next year.
Oh, not precision. Ugh.
All right, so what we're going to cover today, be able to find circumference of circles. Along with that, I'm not sure why I didn't put that in there, but also area of circles. Identify different parts of circles. We're going to talk about that. We've already started talking about it a little bit. Draw this picture. I'm going to turn the light off here real quick. This right in the center here. That's R. I just can't read it any better when I wrote it the second time.
Try making a tessellation with circles.
Yeah, we're going to talk about that. What do you mean try? That's perfect. I drew.
That's tessellation. Unless you include the triangle though.
Right, it's not a tessellation.
Perfect circle.
Draw this circle. We're going to I'm going to just list stuff on the sides and on this side over here. We're going to name different parts of that circle. Please make sure you label everything correctly and draw the segments where they are.
That's the best part.
What's the middle segment?
More like an egg.
Like the middle point, the mid.
R.
E to E.
I mean,
It looks like a P.
I know it was. I tried to draw over it to make it better, and then I made it worse. Is that better? Can you see that one?
Yeah.
I'll just leave it alone then, instead of trying to fix it. Let's start off with the easy ones. Stuff that you knew before today. Give me something that you knew before you walked in here today.
Diameter.
Diameter. So give me a segment that's a diameter in this picture. Segment BA is a diameter.
Radius.
All right. What is a diameter? And I'm not going to put the definition for it up here, but I will some of the other terms when we get to them.
The longest chord in A.
And that's probably how the book would define it: is a diameter is the longest chord. Give me something something that better describes a
Most
diameter.
important line in the circle.
Starts edge of circle, goes to the other edge of the circle, and goes through where?
Through the midpoint.
Goes through the center of the circle.
Radius.
Radius. Give me a segment that's a radius on here.
RC.
RC. Keep that one in mind, Brighton, here in a second. Oops.
Whoa, that's cool for making a circle. Dude, Mystic's the champ of this game. She doesn't like twirl.
She does like every time.
Well, she doesn't like drag it. She just pokes it, and then it's more messed up. And she's like, "Why is it as precise?" She doesn't. She didn't do it right.
Your fingers not
And she
right,
does it like
she's
4 more times.
That's what she does. She like move.
So RC, segment RC is a radius. What's a radius?
Radius is half the
The segment
diameter.
from the middle of the circle to the edge.
Right, it goes from the center point of the circle to the edge of the circle. Something I want to write down with radius. Brighton, give me another radius in this picture.
RB.
RB is also a radius. All right. What do you know about segment RB and segment RC?
They're
They're
congruent.
They're all congruent. All radii are congruent. So
Radii.
radii is the plural. Radii
Yes.
all are equal, or all are congruent. Plural of radius is radii.
With 2 eyes.
Yep.
I feel like I need to ask Steven when that
That's true. It's Latin.
Of course, Josh.
Give me another something else that you told me. Chord.
was. Angle G.
Tell me a chord up here.
ED.
Segment ED. Please make sure you're using your symbols. Segment ED, 2 letters to name a segment. Segment symbol over top. ED is a chord. We'll write a little definition here. Segment. That does what?
Connects 2 points of a circle.
Connects 2 points on a circle. Segment connects 2 points on a circle. Now be careful, because if I draw a circle, and what a lot of you think, if I hold up this circle that I have here, and I ask Marissa to touch a point
And you're just gonna put this.
in the circle, or touch a point that belongs to the circle, go ahead. Notice, what did she do?
Yeah.
On the edge. This point right here, is that part of the circle?
Yeah.
No. All this stuff that's inside here isn't actually part of the circle. The circle is this, the edge. So when you're inside the circle, you're not actually part of the circle.
What about the center?
All right, even the center point. And that's the next thing I'm going to put up here. The center point. In this case, the center point is R. When we name a circle, when we name a circle, that's what we use, is the center point, and you name it this way. Circle, it's a little circle with a dot in the middle, and then just that center point. So when we were naming triangles and squares and rectangles and all other polygons, we always used actual things, actual letters or points that dealt with that certain shape, that were part of that shape. Point R is not actually part of this circle. It's the part that we use to name the circle, but it's not actually part of the circle, because the points that lie on the outside of the circle are actually the parts.
So it looks like a giant or.
Yeah. Yeah, so probably what's not a good letter to use to name a circle?
R.
R. So probably a lot of times you'll see
Or
them
N.
use C,
On.
yeah, or N or anything like that. So they'll use C a lot
It's not
for that. They'll use Q a lot.
W.
So that's the center point. What right there is the center point, and we name the circle with that little symbol and one letter, that center point letter, and that's it.
You didn't close the parentheses.
Number 5. Anything else?
Angle GFA.
Secant.
Angle GFH. What kind of angle is GFH?
Inscribed it.
Inscribed angle. So let's write inscribed angle. And the example is angle GFH. What's an inscribed angle?
Angle with with 3 10 points touching and being inside the circle.
Right. The main thing is that the vertex is on. Man, what's going on here? Is on
Arc.
the circle. So the vertex is on the circle. The vertex has to be on the circle. Now what Austin said is true, but with an angle, does it stop here at G? No, it keeps like going out, right? At H, keeps going out. Because the sides of an angle are raised. Inscribed angle is going to be important because we're going to learn how to find the measure of those inscribed angles and lots of other angles that we deal with.
What?
Does anybody see the other angles in this picture?
Yeah, angle ARC.
Angle ARC. Anybody know what kind of angle it is? It's a tough name.
Right angle.
That's maybe. Who knows?
Radius angle.
Close. That's a good guess.
1/4 the angle.
Inscribed.
1/4 the angle.
Right. This is what it's called.
That was too.
It's called a central angle. So an example of a central angle is angle ARC. Let's not use angle ARC. It doesn't matter. We'll use ARC. I didn't want to use, how come, because it says arc and I don't want anybody to look back at this and look back at their notes and think central angles and arcs are the same thing or something.
Do CRA.
Is an RT.
Yeah, we could have did CRA, that'd probably been better.
Oh wait.
Let's mark it out.
No, I have to erase that.
Angle CRA, you don't have to if you can.
Is there gonna be a dumb thing
I don't
that
wanna
we
get
memorize?
confused.
Angle
that
CRA.
says two central angles or supplementary?
Yeah, it could be. Alright.
I'm not gonna look in.
If I was down at the copy room earlier today and I seen like a 3rd grade paper that some teacher had left laying down there. And they had something like this and it had it shaded in. So they're doing the same thing in 3rd grade that we're doing up here. They said, their question was, what fraction, what fraction of the circle is that shaded part?
We need to find X.
1/4, alright? And what we're going to do with that, we're not going to say what fraction of it is it. We're going to ask what the measure of that central angle is.
Ugh.
So what's the measure of that central angle?
90
90 degrees. And how'd you know it was 90 degrees?
Because it divides into 4 pieces.
So what's a whole circle?
360.
So let's write that down. Circle is 360 degrees. Now you got to be careful with that because we just got done dealing with all those quadrilaterals and all their angles added up to be how much? 360. The quadrilaterals was 360, right? So all 4 angles of any 4-sided figure add up to 360. Is that the same idea for a circle? No, a circle is a little different kind of angles because I don't who was it? Somebody in here, was it Brighton that we said was supposed to go over there and count the angles on the circle that day?
No.
Who was that? I thought it was somebody in here.
Maybe it was Jason.
It wasn't somebody in here. It wasn't Weston. Weston, was it you?
You don't have to tell me
We have to find the
Okay,
5th
do
one by the
anything.
end of the year.
They still class.
How many angles does a circle have?
Infinite. 1. That was my
None.
guess.
Circles don't have angles. So listen. So circle 360 degrees, a little different. Josh, I'm gonna throw something at you guys here in a minute. Circle is 360 degrees, different than the angles adding up in a quadrilateral. What else?
Does that mean 4 radiuses and like, what were you gonna write 4 right angles?
Yeah. So if you drew in a diameter, then you drew in another diameter, and you knew one of them was a right angle, all of them would have to be right angles. Or if you just draw in 2, and this is something we're going to get to, if you draw in a diameter and another diameter, what do you know about all 4 of those angles? Brighton sort of mentioned this. They all add up to be 360. What do you know about these 2 angles?
There.
Congruent because they're vertical angles. What do you know about these 2 angles? They're supplementary.
Nailed it.
Right? So you know all that stuff. Give me something else that we know about the circle. Something else that you guys told me.
What were you going to write on central angle?
Secant.
Oh, central angle. Sorry, I forgot central angle down here. For central angle, where's the vertex loaded for a central angle?
The
Vertex is
midpoint.
the midpoint.
Don't say midpoint.
Center point.
The center point. So vertex is at center of the circle. So the vertex is at the center of the circle. So central angle always has its vertex at the center, and inscribed angle always has its vertex on the edge of the circle. Give me something else that you guys told me about. We just discussed all the stuff that's left a couple minutes ago. So just tell me one of them.
Would BRC be a central one?
BRC is a central angle also. So an arc. Let's do an arc. What is an arc?
It's a big boat that
It's
carries animals.
any points between 2 points on a circle.
All right. So an arc is try to find this.
I spell arc wrong on the quiz.
Oh, zero.
How'd you spell it?
Zero.
Spell ARK like the ship.
No. A-R-C-H.
That's arch.
I did too, and I think, I'm not sure if I erased the H or not.
All right. An arc
Q in there.
is let's see what's the best way to describe it. 2 points on circle and all points between them. That's too long. I didn't really want to do that long a definition. Hopefully you can understand what an arc is without all that. Now we talked about with an arc,
Oh, so it's like you can name it anything.
there's actually 3 different kinds of arcs.
There's a half arc.
I don't know what they're called.
You guys said them all earlier.
Major, minor, and semicircle.
Alright, so let's start with a minor arc.
A major arc.
What's true about a minor arc?
It's less than half the circle.
Alright, less than 180. It's less than 180 degrees. So you measure arcs. Arcs are measured in degrees.
So, in terms of like comparing to angles, it's like a cube.
Right.
Instead it's like with an arc.
Right. So a minor arc's like the smaller one. Name me a minor arc in this picture.
F-C.
FC.
Wait, no, that's, no, F-A.
FA?
Yeah.
So from here to there, everybody agree with that being a minor arc?
Yes.
Right, so when you name an arc, this is the way you name it.
Come on, Emma.
When you name an arc, a minor arc, watch the symbol. You name it 2 letters, and then the arc symbol is a little arc.
Oh, that's cute.
Make sure you make that arc symbol different than what symbol?
The segment symbol.
Segment symbol, because if you are just writing something real quick like you do a lot of times,
I do.
I'm not going to be able to tell whether that's an arc or a segment. So make sure I can tell the difference, all
Bring out
right?
the ruler and make it.
Are there like different ones for like the minor arc and the major arc, or is it just all the like when you write it, like the little arcs above it?
Mhm.
Is that just for all minor, major?
This is for minor for now.
Oh,
Major's basically going to be the same way, but we're going to talk about that here in a second.
You have to make it like.
So for a major arc, what do you know about a major arc?
It's bigger than 180.
All right, so more than 180 degrees. It's more than 180 degrees. But major arc's more than 180 degrees. Somebody name me a major arc in this picture.
Angle.
C.
Oh, say it again, EF?
B to F.
B to F. So everybody watch, make sure you understand this. B to F.
No.
No, the other way.
How do you do that?
Yeah, how would you do that? Because what's it normally, if I tell you to go from B to F, what are you gonna do?
Clockwise? You gotta know that.
You gotta know which direction you're going, right?
F-
So, go F to B. What might you have to do here? So that,
Half-wise speed.
you could use something like that. When you get over to Algebra 2 and pre-calc and stuff like that, and you're dealing with the way something is moving, or physics or something, then, listen, then you'll use that. You'll use clockwise 250 degrees, or counterclockwise 390 degrees.
So this is
All
clockwise.
right? Now, this isn't that way, though. There's an easier
B
way.
to F.
If you wanted to tell somebody to go from B around the circle this way to F, what's going to be the easiest way to do that? Instead of saying clockwise or counterclockwise or right or left.
Major.
Forward.
How about this?
What? That looks exactly like it.
Right,
Oh,
3 points.
Instead of using 2 letters, how many do we use? 3. And what's that tell the person?
But you have to go to B, then H, then F.
Start at B, go through H, and you end up at F. Somebody name that same arc a different way.
What do you want the
B, C, F. Would that tell somebody to walk the same part of the circle? Yeah, give me another way. B, G, F would work.
BDF.
B, D, F would work. Those are all the same arc. So when you're doing a major arc, use 3 letters. So maybe write that down here. Major arc, use 3 letters to name it. Always use 3 letters to name a major arc. What was the last arc that you guys told me? Semicircle. What do you know about a semicircle?
It's 180.
It's exactly 180 degrees. So semicircle's 180 degrees. When you name a semicircle, guess what you're going to have to do?
3 letters.
Use 3 letters again. So with the semicircle, you want to use 3 letters also. Name me a semicircle in this picture.
BFA.
BFA, I heard.
Oh, that's not
What goes right along with the semicircle? How are you going to know when you have a semicircle?
when you
use the diagram.
when you
When
find
you have a diameter. So somewhere in here you might want to just make a little note to yourself. You have a diameter. That diameter splits the circle into 2 semicircles. Every diameter splits the circle into 2 semicircles.
But that same,
Did you figure it out?
well, no, I know. I was,
This is probably all.
All right. Let's see. Are we missing anything here?
Amount of room.
Center,
Stop there.
radius, diameter, chords,
Is way too big.
the angles. One other thing I'm going to say, just for you guys, I probably won't mention this in most of my other classes. So if I draw in a diameter there,
looks like an egg.
That's a good point.
Hey, stop it. It does.
if I draw in a diameter and then I draw this. If I could draw it. It's an inscribed triangle. Anytime you have an inscribed triangle, and you use this a lot when you're trying to measure things that are sort of like circles, they don't have to be exactly, you get a lake or something. A lake's probably not exactly a circle. You don't find many lakes that the contractor, whoever built it, built exactly a circle, or whoever you think that created the earth, when they built it, built exactly a circle, and they didn't make the lake exactly a circle, right? If you have this, and one of the sides of the triangle is a diameter of the circle, can anybody guess what kind of triangle that's going to be?
Equal.
It's going to be a right triangle. It doesn't matter. It doesn't matter how I draw the circle, or how I draw the triangle inside of it. If I draw something way down here like this, what's that angle out here always going to be? A right angle, right angle.
Oh, so it's the angle that's in the void.
So no matter how you do it, you have a diameter there. Maybe you make the triangle something that looks more like that. Guess what that angle's got to be? It's got to be a right angle. And that's real useful, because if you can set up a circle and know that you have a diameter, and you connect the end point of the diameter to another point on the circle, and then back to the other end point of the diameter, you know that that angle that you formed will always be a right angle. Always. Then once you know you have a right triangle, what are some things that you can use on it?
Pythagorean.
Pythagorean's theorem.
18 minutes out.
Right leg theorem.
Opposite.
I've never heard of that theorem.
Well,
Is that like the chicken leg theorem or something?
no, but like leg theorems and stuff.
All right, so all those leg and altitude theorems and all that, SOHCAHTOA, sine, cosine, tangent, all that stuff. All right, so if you remember that, that's helpful. Hopefully we'll get to more about that. All right, draw this picture. I'm going to draw a couple of things in here. I'll call this point Q this time.
For this unit, I need to bring in like a little like thing where I can trace the circle.
Oh, a compass.
Oh, I know what we forgot on the other one. Oh, well, we'll get to it. All right, on this one,
Well, that's
got circle Q, and we already talked about this. We didn't talk about this. We talked about this one. What's line CB called here?
a
Secant.
Secant. And actually, we're going to call it a secant line, just because I never thought about it before. I always just call it a secant. But when you get to Algebra 2 and pre-calc and higher level maths, we talked about sine, cosine, and tangent as the trig ratios. There's actually 3 other trig ratios also that you use with right triangles. And one of them is just the secant. Well, I don't want you to get confused, so when you get to those higher level math class
forget it.
and you start talking about secant, don't get that secant confused with a secant line. All right, a secant line is a line that goes through a circle. Now, could it go through the center?
Yeah.
Yeah,
Diameter could be a secant.
right, diameter could be part of the secant. All right, so all a secant is any line that runs through a circle and touches the circle at exactly 2 points. Anybody, when you were reading some of that stuff, know what this one is?
A
The line.
Really?
Yep. If I take this line,
What is on the back though?
if I take this line,
Here's the secant.
I take this line and I lay it on the circle,
Tangent.
how many times does it touch the circle?
one.
Exactly 1 point. All right, any line is going to touch it at exactly 1 point.
Those are good.
And that's called a tangent line. And again, I'm going to put the word line with it. Normally I just call it a tangent, but a tangent line because you don't want to get that tangent confused with
The other
sine, cosine, and tangent. 2 completely different things.
And on the calculator.
Huh?
Is there like a sine line too?
No.
Sine line.
So tangent, what tangent means, tangent sort of means it's like right next to it, okay? So when you're talking about a tangent, this line isn't actually in the circle, but it's right on the circle, okay? So it's touching at exactly 1 point.
So it's on the circle rather than through the circle?
Right.
Of one.
Touches it at exactly 1 point. Anybody have a guess as to what this point right here is called?
Tangent point.
That's very
Gosh,
close.
dang it, Pete.
Point of,
Tangent.
exactly. It's the point of tangency. If you haven't figured it out by now, math people
Are
really,
extremely creative.
really creative.
Just sitting around like,
What the one?
Some kid like Bright made it.
What crazy name could I give this? Well, this is a tangent, so I'm going to call this point Fred. No, they don't do stuff like that. They just name it what it actually is.
Imagine how like much more difficult math would be if they came up with different names.
Screw names.
This is the room. This is the
So this point of tangency is the point where that tangent line touches the circle. And it's the only point where the tangent line is touching the circle. And I'm not going to go through all this, but can anybody guess what that chord right there is called?
Secant C chord.
Close.
Secant chord.
It's just a secant chord.
Oh my
We already
God.
went over that. We already went over that. I did.
Oh yeah.
Alright, the other things that I forgot on the other one, to find circumference. What's the formula to find circumference?
Pi r squared.
No.
No.
2 pi r.
2 times pi times radius.
Oh,
It's on the board.
And what's the other one?
I wasn't even looking.
And what's the other one? How come it's got 2 different formulas?
Because diameter is 2 pi.
Alright.
Or 2 r.
2 times r is the same as diameter. So you probably want to use this formula when they tell you the what?
Radius.
When they tell you the radius. You probably want to use this formula when they tell you what? The
Diameter.
diameter. Does anybody know where pi came from? Is that
Isaac
some-
Newton.
Isaac Newton made it up?
Yeah. Oh, that's all I
He
know.
was eating pie, came up with it.
And
No,
he just
he
said,
ate
okay,
pi.
I'm going to make up this number,
I'm gonna make it an infinite number.
3.141527, so on and so on. I'm just going to make it up. Some math person did that?
3.145.
No, it looks like a Japanese
Dude,
character.
Mr. Studebaker can say like the first like 40 numbers.
Do you remember?
My dad just gave to the
Because he's like, it relates to my life.
Listen carefully.
Big circle.
Listen carefully and you'll understand where pi came from. If you take any circle in the world, so if I had this circle,
Mr. Epstein, take a picture of that. That's really good.
That
Don't
was
mess it
really
up.
good.
Draw another
Did
one.
you
to
trace
draw
that
on.
circle or something?
if you take this circle and you measure the distance around it, so that's the circumference, right? And I divide that by, what's that segment called?
Diameter.
The diameter.
It's always pi.
Guess what I get every single time? 3.14 whatever. No matter what size the circle
Who
is,
came up with the
whether it's that big, whether it's this big,
Seriously.
if you take the circumference, the distance around the edge, divided by the distance across going through the center, you always get that number pi.
That's crazy.
Just drew an
All right.
artificial horizon.
So that's why you have the pi symbol.
That's awesome.
All
Why
right?
did they pick that symbol? Why couldn't it have been something?
Why can't it be like a
Pick
piece
that
of
symbol.
pie? It was some
Basically. They could have picked whatever. Pi, that's a Greek letter, so I don't know why they used that
Is it
certain
actually
Greek letter.
No, I was at like.
3.14.
All right, the other thing with this, watch on this one. So using that right there, a lot of times we'll use these formulas, but you'll know the circumference. Maybe you don't know the diameter, right? Because I made this circle, I didn't measure the diameter, but if I wanted to find out the diameter, I probably wouldn't want to take a ruler and just try to measure across it, because am I ever going to get it exactly in the center? No. So if I was looking for the diameter of this circle, I could take the circumference, the distance all the way around the edge, and divide by
Oh,
pi, and what's that going to leave me with?
the diameter.
The diameter. So you've learned these two formulas, but this formula is also a real useful one. Circumference divided by pi, because that gives you the diameter of a circle. What would the other formula be for this one? Circumference divided by what? 2 times the radius. No, 2 times, sorry, pi, and that would equal the radius. So those are useful formulas if you're looking for the diameter or the radius. The area of the circle, pi times radius squared. Is pi times radius squared the same as 2 times pi times the radius? Squaring the radius means r times r, not r times 2. So don't get those two things confused. Remember that area is always in square units. So meters squared, feet squared, inches squared, miles squared. Circumference of a circle is always just in regular units. Inches, feet, miles, whatever the units happen to be.
Light years.
Light years.
That's intense. Solar days.
Alright. Wasted a bunch of time because you guys talk an awful lot today. So you only have 10 minutes. This is due before you leave.
Heck, guys.
I'm going to write it over here to the side so I can put the assignment up here. You can use a piece of scrap paper to put it on if you want.
That'd be great.
I'm getting 4.
Get started, don't mess around, because you won't have time to get finished if you do. This assignment's due before you leave. The next, the actual homework assignment is up here now.
Do I have to do this? Correct?
What
Yeah,
shot
you have to do the 2 through 15 first before you leave. If somebody wanted to work some of them out up on the board, they could.
Peyton, your game's up.
No.
It's
Wait,
finished.
wait,